This is GCE A level chemistry 0715. Section C, organic chemistry, June 2022, paper 2. We are continuing with question number 6. Fellow learners, I just want to remind you that if you haven't subscribed to this channel, please take some time and subscribe to the channel so that all the videos I have now and I'm still preparing, you'll get them all. Thank you. Thank you for taking your time to subscribe to my channel. Let's get started. We are starting today with Cameroon GCE A-Level Chemistry 0715, Section C, Organic Chemistry, June 2022, Paper 2, question number 6. Now, it has to do with some calculation, analysis. Question 6A reads, an organic compound Y on analysis was found to contain 35.0% carbon, 6.6% hydrogen, and 58.4% bromine. Molecular weight determination of the compound gave a value of 136.9. The relative atomic mass of carbon is 12, relative atomic mass of hydrogen is 1, and the relative atomic mass of bromine is 79.9. Question number 1. Calculate the empirical formula of the compound. Once more, 6A1. Calculate the empirical formula of the compound. Yes, you should know, you should be versed with this. I know that when you see such questions, what should come to your mind is you should know how to calculate empirical formula. Okay, going back to our stoichiometry, going back to how to calculate the number of moles. You know, initially where you must have been told, or you must have done this in class, how to calculate the number of moles. And calculating the number of moles, we have the mass divided by the molar mass, or because the molar mass of any compound is 1 mole of that compound. The mass all over the molar mass, or the given mass divided by the relative atomic mass. So in this case, we have been given by the relative atomic masses, and we have been given the percentage by there are different percentages. These are the percentage by mass of each of the elements. Percentage by mass. So in that case, we are assuming the percentages to be the masses of the different elements. So, and in calculating the number of moles, we should, knowing that moles will be equal to the given mass, which is the percentage we are going to be using, divided by the relative atomic mass. We'll have the number of moles, and from there we have the molar ratio, and the empirical formula is the simplest one. So now let's move on. Okay, in doing this, I did some calculation here for you. I want you to just have a look on it. The compound Y contains carbon, hydrogen, and bromine. This is it. That is compound Y. So compound Y has this percentage by mass. We have 35, 6.6, and 58. Related atomic masses are 12, 1, and 79.9. And the number of moles, as I told you, you divide the masses or the percentage by mass by the related atomic masses, and you have it. And if we do this, we have the number of moles. And when we have the number of moles, to have the molar ratio, we divide it by the smallest. And when we do that, we will have our molar ratios will be 4 moles of carbon, 9 moles of hydrogen, and only 1 mole of bromine that is there. So this is all what we have. And the empirical formula for the compound Y will definitely be C4H9 and B arrow. That will be the empirical formula. Now we will have to go to the second part of it. If you did this work here, and now say empirical formula of Y for compound Y is this, you will have all your scores outlined like this. Thank you for watching. Now let's go to the second part of it. The second part of it is compelling us to do what? Determine the molecular formula of the compound Y. The molecular formula of the compound Y, because we have been told the molecular weight determination of the compound gave a value of 136.9. Okay, determine. We have to use that here in determining the molecular weight. And the molecular weight here, as I know, I think I also did part of it here. Here, the molecular weight, the molecular weight here is what? We had our formula. This is the molecular weight. In determining our molecular weight, you have to look for the molar mass. In determining the molecular weight, you have to look for the molar mass of the compound, and the molar mass of the compound, you write the number of the compound down and put a certain number n. Since this is our empirical formula, this is not the full formula of the compound until we have it based on the molecular weight that has been given. So you will have to write the the empirical formula down times a certain number of moles n. That will give us the molecular weight. Now, if we calculate the molecular formula, the empirical formula, calculating the molecular mass of the empirical formula, we will have 12 times 4. We will have 12 times 4, which is 48, plus 1 times 9, which is 9. Then 79.9 times 1, because we have only 1 year. 79.9. When we add all this, we will have a total of 136.9 N. We know N is the number of moles. So N, which is equal to our molecular weight. Now, to have the N here, to have the value of N, we need to make N the subject by dividing all by 136.9. And if we divide that, N is equal to 1. So if we substitute N here as 1 times all this, our molecular formula now, that will give the molecular weight of 136.9 will be officially will be C4. The molecular formula for the compound Y will be C4H9 and B arrow. That will be our molecular formula after doing this calculation here. That's 2. Let's go to the third part of the question, which is part 3. Section 3 has to do with how can you test for the presence of bromine in the compound. Yes, I know that you have many tests for double bond, tests for bromine. All of them, you have them. I trust you have them. But however, this is a haloalkane. How are you going to test? How can you test for the presence of bromine in this? There's one thing you have to do in testing for the presence of bromine. One thing you have to do is, they have asked you a question. You have to analyze. You have to tell them, you will do this, you will do this. Since it is an experiment, you will have to say observation. You put your observation. Conclusion. The 3 steps must be there. If you have been writing directly and just writing stories, it's not proper. How can you test for the presence of bromine in this? What you are supposed to do is, remember, you are not supposed to be giving the test. I mean, you are not supposed to be just outlining the test. No. You have to describe how it is. How can you test? You have to describe and tell us how the procedure goes. So what comes to your head is, okay, bromine. Test for bromine. Ah, you don't have any particular test for bromine? Okay, let me go to my inorganic chemistry. This one is a halocane. In my inorganic chemistry, there was a test for halides. Oh, what are halides? Okay, we are talking of the halogens. Oh, there's test for chlorine. That's for chlorides, presence of chloride. There's test for bromine. That is a test for the presence of bromide ion. Oh, there is test for iodine, which is the presence of iodide ion. Okay, I can use this test to do that. That's what is supposed to come to your brain. So now you are going to use test for halides using acidified nitrate, acidified silver nitrate. So you can say test for halide tolerance reagent using, yeah, you are going to test for halides. So since it's test for halides, you know test for halides very well, but we have been specified presence of bromine. For you to know how you can test for the presence of bromine, what you are going to do here is that to a solution, so you are going to use in this case, you are going to use um, you are going to use acidified silver nitrate. You are going to use acidified silver nitrate. So what you will do in this reaction is that you will say you will say to a solution of bromopropane, because the molecule is bromopropane, to a solution of bromopropane in a test tube, add a few drops of what? Silver nitrate. Add a few drops of what? Nitric acid to remove the impurities in it. That's what you are supposed to do. Add a few drops of the acid, that is nitric acid, to remove impurities. That is the procedure. Just 3 lines is okay for you. You are not being asked to write the equation, but I will explain that later on for the purpose of revision. So what is required of you is step number 1: to a solution of bromobutane in a test tube, add a few drops of nitric acid to remove impurities. Then number two, once more, please. As I said, you have to outline it from as a procedure, as an observation, and a conclusion. That to a solution of bromobutane in a test tube, add a few drops of nitric acid to remove impurities. Full stop. If bromide ion are present, a cream precipitate of silver bromide are formed. Full stop. The formation of a cream precipitate of silver bromide indicate the presence of bromine in the compound. That's all. Once more, procedure. To a solution of bromobutane in a test tube, add a few drops of nitric acid to remove impurities. Observation. If bromide ions are present, a cream precipitate of silver bromide are formed. Conclusion. The formation of a cream precipitate of silver bromide indicate the presence of bromine in the compound. Full stop. So when you do like this, the examiner knows you know what you are doing. I think I have some information here for you regarding that. I think I have something here on that for you. If I'm not mistaken, I have some little information here for you regarding that. But if that is not, I thought I had got something information here more for more emphasis for you. But if you can't find it, Don't bother yourself. You can't find it, don't bother yourself. Everything is okay. Okay, let's move on. Um, then again, for the purpose of revision, for the purpose of revision, I will also say that for the purpose of revision, what I will tell you is that when you have such a compound with any halogen involved, you should remember your test for halides. You should remember your test for halides. Always remember your test for halide, because if there was a if it was chlorobutane, what you will find there will be what you mentioned the same thing, but your observation with what your observation is that if your your observation is that the white precipitate are formed, and your conclusion should be that the presence of white precipitate indicate the presence of chlorine in the compound. On the other hand, if iodine was in the compound, you would do the same procedure. Then your observation should be that there is the formation of yellow precipitate of silver iodide. And now your conclusion should be that the presence or the formation of yellow precipitate of silver iodide indicate the presence of iodine in that compound. Just the same way we stated that our observation is the formation of a cream precipitate of silver bromide. And we concluded that the formation of a cream precipitate of silver bromide indicates the presence of bromine in that compound. That's how you are supposed to do when it has to do with um, test for halides. And the general formula for test for halide, if is this thing you have a halide. The general this thing for test for halide. Let me see if I have. Yep. Test for halide here. You can say it is X. Let me say the X halide. This I highlight a halide ion. Uh, oh. Okay, if I was to write a general equation here and ask you to do something there, the general equation for halide ion should be something like this. It's what you will have. In this case, it will be the bromide aqueous plus the silver ion, which is aqueous to give what? To give silver bromide, which is a solid. These are precipitates. These are precipitates. So, based on what we have said, you can answer the question like that. Let's go to question number, the B part of it. The B part of it says the organic compound Z, the organic compound Z, the organic compound Z with the molecular formula C4H8O2 exhibits isomerism. What is isomerism? That's the first question. Okay, you should know that isomerism, the word iso means the same. Iso means the same. So now in chemistry, we now say isomerism, we are talking of these are compounds with the same molecular formula but different structural arrangement. Compounds with the same molecular formula, compound with the same molecular formula but different structural arrangement. These are isomers. These are isomers. Then what is isomerism? It's a phenomenon. Isomers are different. Isomerism is a different thing. Isomerism is a phenomenon that helps to describe isomers. So isomerism, now we can say it is the occurrence or it is the existence of compounds. Isomerism, we can have existence of compounds having the same molecular formula but different structural arrangement. Okay, let's go to G. G, give the structures and names of all the isomers of the compound Z. Structures and names of all the isomers of the compound. So we say isomerism is the existence of compounds with the same molecular formula with different structural arrangement. Okay, if we arrange this structure, we will definitely have about 4 different structures, and those structures we call them isomers. So 4 isomers are going to come out from here. So we are going to give the structures and the names of all the isomers of the compound Z. So let's do some work here. Okay, coming here, the compound is C4. If you go there, the compound is the compound we are dealing with is C4H8O2. Let's go back again. The compound we are dealing with is C4H8O2. So here we have about 4 different isomers. I've done some work here for you. There are some 4 different isomers here. We have a C4 H8. So there are supposed to be 8 carbon. We have 1, 2, 3, 4. 4 carbons. Then there are supposed to be 8. So there are 3 carbons here plus 5 here. There are 8. And there are 2 oxygen. So how we arrange C4H8O2 into different structures? We are going to have 4 different structures. And these are the structures I have arranged here for you. The first structure here is what? The first structure here is methyl propanoate. We start naming from here. It's an ester. The first structure here is an ester. We start naming from here. This is a methyl group. And then we start from here and then end here. We say methyl. How many carbon atoms are here? 1, 2, 3. If it's 2 carbon atom, we say ethanoate. If it's 1 carbon atom, we say methanoate for esters. If there is 3 carbon atom, we say propanoate. 4 carbon atom, we say butanoate. 5 carbon atom, we say pentanoate. So in that order. So here we start the chain is a methyl group, and there are 3 carbon atoms here. 1, 2, 3. So we say a methyl propanoate is our first structure, and this is an ester. Then the second structure is we have the second structure. The second structure has 2. The second structure has a functional group here. There's a functional group here. There are even 2 functional groups. But at the end here, the functional group here is this one. It's an aldehyde. The functional group on this side here is an aldehyde. So now, we now say, because the functional group is an aldehyde, and we have another functional group, a hydroxy group, which is attached to this, the first position. This is the first carbon. This is the second carbon. And this is the third carbon. Fourth carbon. We now say the hydroxy group is attached on the third carbon. And we start naming and then ending it with the functional group. We now say it is 3-hydroxy because it's on the third carbon. And how many carbon atoms are there? 1, 2, 3, 4. The parent chain has 4 carbon atoms. We now say 3-hydroxyl butanol. 3-hydroxyl butanol. And it is an aldehyde. Now another structure that also came up is an ester. But this time around, it is not a methyl, but it is an ethyl. Why an ethyl? It has three. It has two. The side chain has two carbon atoms. You can either say it's a methyl if it has one carbon atom. You can either say it is an ethyl if it has two carbon atoms. You can say it is a propyl if it has three carbon atoms. You can say it is a butyl if it has four carbon atoms. You can say it is a pentyl if it has five carbon atoms. But in this case, it has two in this compound here. So we say it is ethyl. Then the parent chain is what? Then here is ethanoate. This is ethanoate here. So ethyl. Then there are two here. We call it ethanoate, and that is an ester. Then the last one is the compound we're given. We said it is C4 H10 O2, and manipulating these structures to look for the different isomers, we got a carboxylic acid, which is 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4. This is the structure. And this is the carboxylic acid. And the name of this carboxylic acid is what? Is a butanoic acid. And this is a carboxylic acid. So going through, we have seen that from all these, there are different functional group. We have this is a carboxylic acid functional group. We have this an ester. This an ester. This is a functional group. We have this an aldehyde functional group. We have this an ester functional group. All through the structures, there are only functional groups displaying functional groups in the structures. So if you fellow learners, if you can develop structures like this, name them according to the IUPAC system, and know their functional groups, then you are up to date. So if you do like this, that section, you are fine. You have all the scores for the different isomers of C4H8O2. Thank you. Let's go back there. Let's go back to the question section. Give the structures and the names of all the isomers. We are done with that. Now, okay, number 3. What kind of isomerism could be exhibited by the compound Z? What kind of isomerism could be exhibited by the compound Z? This compound, if you look at it, what type of isomerism? There are different types of isomerism. We have optical isomerism, under stereo isomerism. We have optical isomerism. We have geometric isomerism. If we go now to the structural type of isomerism, we will have functional group isomerism. We will have functional group isomerism. We will have different types of isomerism. So under this, the structures have been displayed. But what was common is functional group, functional group, functional group, functional group. So what kind of isomerism could be exhibited by the compound? I can say fully it is a functional group isomerism. It is a functional group isomerism. Functional group isomerism. This is a functional group isomerism that is being exhibited by these isomers here. Okay, now the C part, we are now changing section. The C part is now dealing with another organic compound. They say the compound CH3CH into CH3 CONH2 has a functional group of CONH. A functional group of CONH. What is a functional group? Oh, even though we have been talking of functional group, but how can you define a functional group? What is a functional group? That is the question in front of us now. A functional group, remember that a double bond is a functional group. A single bond is a functional group. That's for alkanes, homologous series. A triple bond is a functional group. The halogen, the location of halogen, bromine, they are giving them their halides. That's a functional group. We are talking of OH, that is alcohol for alcohols, carboxylic functional groups, alcohol functional groups, ester functional groups, amide functional groups, amino acid functional groups, and different types of functional groups. Comprises of atoms, group of atoms, and bonds. So functional group has three ways. Atoms are involved, groups of atoms are involved, and bonds are involved. So we can define a functional group as this is an atom. I can put it here as this. A functional group is an atom. I say this is an atom. This is an atom. This is an atom or group of atoms, or group of atoms, or bonds, within a molecule. Within a molecule that is responsible for the chemical properties. That is responsible for the chemical properties. For the chemical properties or chemical reactions. You can say properties or chemical reactions. Chemical reaction of the molecule. So you have seen that a double bond is a double bond, a single bond, a triple bond. That is also a functional group of alkanes, and alkynes. You have seen that if a chlorine atom is attached to something, we call that a halide. That's already indicating a functional group, something like that. We have seen that if a nitrogen is already indicating an amino type of thing. So we now say it is an atom or group of atoms or bonds within a molecule that is responsible for the chemical properties or reaction of the molecule. That is just all for a functional group. Then let's get to give the second one. Give the systematic name of the compound. Oh, the systematic name of this compound. If I can draw this compound here, this should be the systematic name. Let me draw it here for you to see the compound. This is a compound. I draw the compound that has been given up there. This is the compound I have been given. I drew the compound. We have, this is the compound CONH2. This is the compound. It's a methyl group here, a second methyl group here, oxygen, and an amino group. So you see now that it has an amino group here. In this amino group, we say there is a carbon atom there is a carboxyl. This is a carbonyl carbon atom. This is a carbonyl group. A carbonyl group is this group like this. A C oxygen. That is a carbonyl group. So, and this is the compound. This is the carbonyl group here. So we say a carbonyl carbon attaching itself to a hydrogen, it gives what we call an amide. A carbonyl carbon, let's say this is a carbonyl carbon here. This is a carbonyl, this is a carbonyl group. This is a carbonyl group. If a carbonyl group, in the carbonyl group, if the carbon atom there is attaching itself to the nitrogen, we call it an amide. Look the compound again once more. This is the compound. This is the compound that you were given. No, this is the compound. This is the compound you were given. This is the carbonyl group here, CO. So the oxygen is here, and the carbon is attaching itself to the nitrogen. So what do we say it is? Here we say in this compound here, when the carbonyl carbon is attaching itself to a nitrogen, we call it an amide. This is an amide. And in trying to give the systematic name of this compound, we have carbon here. This is the first position of carbon. That's the first position of carbon. This is the first position of carbon. This is the second position of carbon. And this is the third position of carbon. And there is a methyl group. There's a methyl group here on the second carbon. So we group this. We group the whole of this. We group the carbonyl group and the amino group. We group them as an amide. We group them as an amide. So what we are going to do here is this. The methyl group is located on the second carbon atom. We now say it is 2. Then our prefix is methyl, 2-methyl. Then our parent, how many carbon atoms are here? The chain is 1, 2, 3. There are 3 carbon atoms. So the systematic naming for that compound that was given, we will now say the systematic naming is, according to the IUPAC, is 2-methyl propanamide. 2-methyl propanamide. 2-methyl propanamide. Propan because it is 3 carbon amide. So that is the systematic name for it. So it's 2-methyl propanamide, which we can still write it here. The systematic naming as what is the systematic naming? Give the systematic naming here. We say it is 2-methyl. Say 2-methyl propanamide. Okay, propanamides. 2-methyl propanamide. Okay, after finishing like that, which spectroscopy? Number 3, which spectroscopy method? Which spectroscopy method can be used to determine the presence of double bond in the molecule? There are many techniques that are being used to determine double bond, single bond, even group of element, even functional group. They use that for functional group. They use that for double bond to determine the type of bond. They even use that to determine the strength of the bond. And the mostly used technique or method is the nuclear magnetic resonance, the NMR spectroscopy. The nuclear magnetic resonance spectroscopy is the one that is mostly used to determine the bond, to determine the side chain, to determine the strength of the bond, and even the different molecules that are there. That one is used. And in this method, in these techniques, they study the molecules, recording their interaction, the interaction radio frequency, electromagnetic radiation in the molecule to determine their structures, the bond types, the number of molecules that are there. So this NMRO, that is, we write it as Which method can be used? Yeah, we can use. You can write it here as. There are other methods. You can write it here as. We can say nuclear. You can say it's a nuclear magnetic resonance. Resonance. Resonance in bracket in bracket we can put it as um, N M arrow. Yeah, and arrow spectroscopy. Spectros uh, spectroscopy. Yep. Ah. Okay, you can use nuclear magnetic resonance. That's NMR spectroscopy. You can still use. There's another one again. You can use this one. Let me see. You can use this. You can even use this infrared spectroscopy. Infrared. Yeah, you can also use infrared. Infrared. Infrared spectroscopy. Spectroscopy. With that, I think that one. These are the major two that you can easily have. Nuclear magnetic resonance (NMR) spectroscopy and infrared spectroscopy. You can use these two. You'll be okay. Okay, let's go to D. D. The compound CH3CHNH is an amino acid containing an asymmetric carbon atom. The word asymmetric. The word asymmetric. The word asymmetric. When you read your question, very, very, very careful. Look at the concept. Asymmetric carbon. Asymmetric carbon atom. What is an asymmetric carbon atom? An asymmetric carbon atom is a carbon atom when you are dealing with organic compounds. A carbon atom has four groups. For a carbon to obey the octet rule by having 8 electrons in its outermost shell, it must bond to four. It must bond to four different atoms with each having a pair of shared electrons, and all totaling eight electrons in the outermost shell. So for carbon must have four atoms at the outermost shell bonded with. If carbon has four different atoms, not like in the case of methane, in the case of methane has a carbon, hydrogen, 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 hydrogen. No. If an atom has, let's say this is carbon atom, it has there's another atom, and then there's atom B, there's an atom C, and an atom D, which are all A, B, C, D are different. Let's say A is not equal to B, and B is not equal to C, and C is not equal to D. Then that is an asymmetric carbon atom. A carbon atom attached to four different groups or bonded to four different groups. This is what we call an asymmetric carbon atom. And if you were asked to put an asterisk on an asymmetric carbon atom, your asterisk is supposed to be here. Your asterisk is supposed to be here on the carbon atom here. That this is the asymmetric carbon atom. Thank you. I have an example here for you. Okay, let me look this example here for you. to better understand the concept. Look at asymmetric carbon atom. What we're talking D1. You have this is amino acid. Here, this is a carboxylic group. It is different. This is the amino group. It is different. This is a methyl group. It is different. This is a hydrogen group. It is different. We call this carbon atom attached to 4 different group of atoms or different atoms or group of atoms. We call this carbon atom an asymmetric carbon atom. And that is why I said there is an asterisk there. So in your question, you are supposed to put in the compound we're given, this is where the asterisk is supposed to be. Okay, let's go to the next section of it. We are done with D1. Okay, D1, let's go to, we have put the asterisk, you have seen it on that compound there. Okay, D2, give the structure of the compound in the following medium. This is the same structure. That is amino acid. It's an amino acid containing an asymmetric carbon atom. Now, give the structure of the compound in the following medium. The structure of the compound in the following medium. So the structure in acidic medium. I want to give you the structures in acidic medium. You have to write the equation and now underline the structure. But if you have a rough sheet of paper, you do an equation there and just place the structure here. So in acidic medium, let me show what is happening there. In acidic medium, let me just show what is happening there. In acidic medium, okay. In acidic medium, this is the structure. How is this structure like this? What is happening here is this. Remember, this is a compound that is formed from something I want you to understand. There's something I want you to understand better. There's something I wanted to understand here regarding this structure. Okay, by the way, this is the structure you were given. What happens here is this. In this structure, this is an amino acid. They call it amino acid because this is the carboxylic acid group, and there is an amino group there. So they call it an amino acid. This amino acid here, because it has an acid and it has a basic group, this is like acting as a base, and this is also acting as an acid. So they interact between themselves. This one will, because of the lone pair of electron, because the one has a lone pair of electron here, it will accept a pair of electron. This one will accept a pair of electron and will accept a proton, sorry. Because of the lone pair of electron here, and is acting as a base, it will accept a proton to become this structure here. And it will be NH3 to form this compound, NH3. Now, this other one, because it's an acid, it will do what? Because it's an acid, it will grab a proton. That's a hydrogen ion to form an acid. This is what is happening here. That's what they wanted to do. This is the situation here. You see, this is a carbon atom here. This is an acid group. Because this one is the amino group is acting as a base, it will grab a proton. So this proton here, this positive charge here on the amino group and the acid group, they are interacting among themselves. And when a positive and a negative are acting among themselves, the compound becomes a neutral compound. They become the compound become a neutral compound, and this ion from here, the ion, the species, this compound, the entire compound here, we call it a zwitter ion. A zwitter ion. This is a zwitter ion. Implant that the species in neutral solution. So now let's take this and see what happens. The reaction and the compound. You have been asked to give only the structures. You have been asked to give only the structures of not the same. So now in acidic medium, that zwitter ion, how is it going to act? This is a neutral compound because this positive and this will cancel out. This is acting as a buffer solution. A zwitter ion is like a buffer. In a buffer solution, on addition of a small amount of acid or base, nothing changes the pH. So see what is happening here. It's acting like a buffer. So now this is an ion. They ask us to write the structure in acidic medium. So in acidic medium, this is an acid. What happened in acidic medium is that this one being in acidic medium, what happens? The pH, the acidic medium means it has a low pH. So if it has a low pH, it's going to do what? It's going to go up. Raise the what happened with the buffer is that when the pH drops, it manipulates it to raise the pH up. When the pH is too high, it manipulates it to bring it just down. Just manipulating it, not too high, not too low, just in that way. That's what is happening here. In an acidic medium, acid has low pH. So what happens? What is going to happen here is that in acidic medium, the acid acts as a base. Acidic medium means low pH. So the acid is acting as a base. That is going to do what? Accepting proton is going to grab this proton here. This is the acid group. This is the acid group. It's going to grab this proton here. And when it grabs the proton or accepts the proton, it forms the solution, resulting in a positively charged amino acid. So what happened when this acid group, this is the alkaline group, this is the base, which is the amino group, this is the acid. So in an acidic group, it's going to act as a base and accept a proton. Bases are proton acceptors. OH is a base. It accepts a proton like hydrogen ion to form water molecule. So bases, so this acid is going to act as a base to accept this proton. And when it accepts the proton, what is formed? The acid is formed. And allowing what? Resulting in a positively charged amino group. So this will be the structure that we are going to draw. Secondly, if it is basic in the basic medium, the amino acid will act as an acid this time around. In the basic medium, what is happening in the basic medium? The basic medium means high pH. And if it is high pH, it will have to bring it down. This one is acidic one is acting as a buffer solution. This zwitter ion is acting as a buffer solution. So in a basic medium, it means it is in a high pH medium. So in a high pH medium means what? The base is now going to act as an acid this time around, donating a proton from the acid group to the base, resulting in a negatively charged amino acid. Amino acid ion. So now the base is now going to act as an acid. So this time around, you see it here. This base, because it has a high pH, it must do it to bring it down. So what happened? The base is going to act as an acid, donating what? I told you this one has this nitrogen has two lone pairs of electron here. So it's going to donate. Donating a proton. It's going to donate this proton here, one of the hydrogen, to what? to this group. And when it donates to this group, what is formed? When it donates to this group, oh, you see, NH2 is formed, and this one still remains. So when it donates a proton, NH2, one proton is removed, so NH2 is left. The proton adds to this, and a molecule of water is formed. So H still remains. Now, H being remaining means it is acidic now. The pH, which is high, now has gone to acidic level, which is low. That is what is happening. So this is the structure we are supposed to draw in the acidic medium. That is the molecule of water that is being produced. Now, in a neutral medium, these equations are very, very important. Study them very well. In a neutral medium, what is going to happen in a neutral medium? Okay, in a neutral medium, we are showing how a zwitter ion, this is the zwitter ion that we are using, is going to be acting. Now, in a neutral medium, we have both acid and we have both bases. We have both acid and we have both bases. So in this case, on adding the acid, what happens? This is formed. And on adding the base, what is formed? This is formed. On the other acid, this is formed, just like that. And what would be the structure in a neutral solution? This is the structure here. The zwitter ion is the structure. So let's go ahead. And draw our structures. Let's go ahead. So the zwitter ion is very, very important because it resists. It's like a buffer solution. It resists any change in pH. If the pH is increasing, it's getting too high, like in the basic medium, it brings it down to acidic level. If the pH is too low, making it more acidic, it takes it up, making it more basic. So the zwitter ion is acting once more as a buffer solution, resisting any change in pH. So let's write for the zwitter ion, that is the structure in the neutral solution. So let's go back there and write our answers. A zwitter ion, the structure in a neutral solution. So they say give the structures of the compound in the following medium. I was giving those equations just for the purpose of revision. Okay, a zwitter ion in a neutral solution is supposed to be this. Give the structure of the compound. So it is CH3. This is CH3. Sorry. This is CH3. This is a carbon. This is the amino 3 plus. This is this writing's not moving well. This is a COO. That is the acid, and this is, and that is the hydrogen, and we call it zwitter ion. We call it zwitter ion. Okay, now for in the basic condition, we say the structure is what? In the basic condition, it's supposed to be acidic. The basic condition is supposed to be acidic. Basic condition, this is the structure. It's supposed to be very good. It's supposed to be acidic. So the basic condition is supposed to be acidic. So this is a structure plus a molecule of water that's being produced. So that is it. Basic condition. You have this for yourself. basic condition, you have a CH3, you have, in the basic condition, you have CH3, you have a carbon, you have a hydrogen. In a basic this thing, basic, you have, it should be acidic there. So the structure of the compound in the, okay, the structure. Yeah, there's minus here. And there will be what? NH2. So NH2COOH minus. Okay. Now, in this other compound here, in acidic medium, it's supposed to be acidic. Because it is acidic, it's supposed to be basic now. So how do we do it now? We change color. Okay. So it's supposed to be basic. That is COOH. The word NH3 should be COOH NH3. Acidic medium, you see COOH, yeah, the NH3. That's the difference. So now you go back to your question paper, answer sheet, and in acidic medium, you write your structure as CH3, and you write its carbon, and the carbon has an NH3 plus, N3 plus, and you have a hydrogen, and there is a COOH. That is being formed. So in this compound here, we have changes. So these are the different compounds you have here. The acidic is H. Here is H. Here and this and this. So these are the different compounds you are going to find. Yeah. It is basic for basic. Yeah, this is for acidic condition. Acidic medium. This is basic medium. This is a neutral medium. So that is it. Fellow learners, I think we are done for today. Thank you very much for listening. Thank you for the different answers. I'm happy with all this. I will be proud to see most of you with very good grades in chemistry. Thank you. Let's move on. Before we go, I just want to remind those of you who have not subscribed to this channel to take your time and subscribe before you go. My wish for you is understand the basic concept in chemistry so that you can handle the challenges ahead. Thank you very much. Bye-bye.